As a leading supplier of adhesives, sealants, and damping parts for automotive and industry applications, Sika has an increasing footprint in battery assembly. From module to pack level, Sika enables an efficient manufacturing process for durable energy storage systems. Starting with the cooling plate of the battery tray, structural adhesives are used to bond two aluminum sheets, forming channels for the cooling agent to flow through. Sealants are used to cool channels or connectors to ensure proper cooling of the battery over its lifetime. With the increase in hybrid structures, bonding is now the joining technique of choice. Sika offers different chemistries with high chemical resistance against the cooling agent for such applications. The cooling plate is then incorporated into the battery tray, where it's assembled with crash beams and module separators. The battery is a substantial part of the body and contributes to the torsional stiffness, especially for newer electrified passenger vehicles. Also, for commercial vehicles, a robust battery tray is key for long-lasting durable batteries. Sika's epoxy-based structural adhesives help manufacturers increase part stiffness and carry loads in case of a crash, whereas its semi-structural polyurethane anacrylate-based adhesives allow mixed material designs of the battery enclosure. The smallest unit in the battery is a single cell, which comes in different formats. Combining them to a bundle creates a module that is joined together using adhesives. During service and charging, cells generate heat, which needs to be dissipated to ensure high energy output and longevity of each cell. Sika's thermal conductive adhesives are used to join prismatic cells to the bottom plate of modules, combining high strength and heat transfer. Fire-retardant semi-structural adhesives bond lateral and top plates to the cell stack to increase the crash performance of each module and allow cell swelling over its lifetime. The assembly of modules made of cylindrical cells is similar, however the unique cell geometry needs alternative application methods. A thermal conductive adhesive is used to position the cells in a cell carrier. To protect neighboring cells from thermal runaway propagation and avoid vibration, the cavities between cylindrical cells are filled with a potting resin after they have been assembled. Sika offers a wide range of thermal conductive gap fillers and adhesives to allow for heat transfer. They have been developed with a focus on low compression and pull-out forces for a simple assembly and repair process. An outstanding ratio of thermal conductivity and density enables a high storage stability. Electronic parts such as inverters, converters, and onboard chargers need to be protected against environmental influences and need to have a high electrical insulation. Structural epoxy or flexible polyurethane potting resins are used for encapsulation of these parts and offer thermal conductivity and high dielectric properties. After the modules and electronic parts are assembled and connected, the battery tray is closed with a top cover. Sika's silicone, polyurethane, and STP-based sealants have been used for decades in different industries. They are applied fully automated, create a permanent bond between the top cover and tray to ensure gas and water tightness for the lifetime of the battery. In case of a thermal runaway, passengers need to have time to egress the vehicle. Current regulations require an evacuation time of 5 minutes for passenger vehicles and 30 minutes for commercial vehicles. To prevent fire and toxic smoke breaking out of the battery enclosure, the cover needs to be reinforced with fire protective measures. Sika's fire protective coatings slow down the melting of materials such as aluminium or composites. They are automatically spray applied, which allows the use in modular battery platforms and on 3D-shaped enclosures. After closing the lid, the battery is ready for use, but first needs to be tested for tightness. The accelerated curing of Sika's sealants allows an end-of-line pressure test after adequate time. Finally, the battery is mounted to the car body and connected to the electric drivetrain.